Your cat knew you were anxious before you walked through the door. Cats carry a secondary olfactory organ at the roof of the mouth, just behind the front teeth. It's called the vomeronasal organ. Most humans don't have a functioning version of it. The vomeronasal organ is lined with chemoreceptor cells tuned to non-volatile chemical compounds, the kind that dissolve in moisture and linger on skin, breath, and surfaces long after a person has left the room. When a cat lifts its upper lip and holds its mouth slightly open, it's not yawning or grimacing. That expression is called the Feline response. The animal is actively pumping chemical information into the vomeronasal organ. The signal from the vomeronasal organ travels directly to the amygdala and hypothalamus, the brain regions governing threat detection, emotional memory, and the fight or flight response. This is not a detour, it's the main road. When you're afraid, your body releases cortisol and adrenaline. Both hormones alter the chemical composition of your sweat, your breath, and the microscopic oils your skin constantly secretes. A 2016 study in PLOS ONE confirmed that human sweat collected during fearful states carries measurably different volatile organic compound profiles than sweat collected during calm states, distinct enough for trained detection. Your wrist, your neck, and the inside of your elbow are the warmest and most chemically active surfaces on your body. When a cat noses those spots, it's not simply being affectionate, it's reading a report. This sensitivity didn't evolve for your benefit. Cats began living alongside humans roughly 10,000 years ago in the Near East, drawn to grain stores that attracted rodents. Reading human emotional states became a survival advantage in that shared environment. A calm human produces a different biochemical environment than a stressed one. Lower cortisol means quieter sweat chemistry. Steadier breathing means a more consistent CO2 signature. To a cat, your resting state has a recognizable scent profile. It's memorized. A domestic cat's olfactory system contains roughly 200 million scent receptors. Humans have about 6 million. That ratio means your cat is processing a version of your chemical presence that is orders of magnitude richer than anything you can perceive about yourself. Raw receptor count is only part of the story. The vomeronasal organ adds a parallel channel dedicated to social and emotional chemical signals, a second inbox running simultaneously alongside the primary one. Research by Meredith and Brennan, published in Chemical Senses, demonstrated that vomeronasal stimulation in felids activates distinct limbic regions that standard olfactory input never reaches. The two systems don't simply overlap, they deliver different kinds of meaning to different parts of the brain. Researchers at Oakland University in Michigan published findings in 2019 showing that cats adjust their proximity and behavior based on their primary caregiver's emotional state, a response that requires detecting that state before any visible cue is given. Most people never notice this because cats don't react the way dogs do. A dog may pace or whine when it detects stress. A cat recalibrates quietly, repositioning, watching, or withdrawing, leaving no obvious signal that it's registered anything at all. The chemical signals your body produces travel through gaps under doors, through ventilation systems, and on the clothing you leave behind. Distance isn't the barrier you might assume. Your emotional state can precede you by several minutes. A 2021 study led by researchers at Lund University, published in Indoor Air, measured how quickly cortisol-associated volatile compounds dispersed through a standard residential space. Within 4 minutes, detectable concentrations reached rooms the source person hadn't entered. There's a counterintuitive finding buried in the behavioral research. Cats don't consistently move towards stressed humans. Some withdraw. The variable that predicts the response is the cat's own attachment style, which mirrors human attachment theory almost exactly. Ethologist Kristen Vitale at Oregon State University applied Mary Ainsworth's 1970 Strange Situation Protocol to cats in 2019. 65% showed secure attachment, approaching their caregiver for comfort when stressed, then returning to exploration. A securely attached cat detecting elevated cortisol in its caregiver will often move closer, not to seek comfort for itself, but to investigate and remain present. The scent detection triggers the proximity. The attachment style determines its form. The vomeronasal signal can trigger a physical response within seconds. Pupil dilation, ear rotation, a subtle shift in tail position, all downstream effects of that limbic activation. Visible markers of an invisible chemical conversation. Most cat owners have experienced this without naming it. You receive difficult news, your body tightens, and within moments, your cat, asleep across the room, opens its eyes and looks directly at you. That's not coincidence. Research by Smeets and colleagues, published in Psychoneuroendocrinology, found that stress-induced cortisol begins influencing sweat composition within 90 seconds of a psychological trigger. The chemical shift is measurable before your voice changes, before your posture changes, before any visible signal reaches the room. The vomeronasal organ connects directly to the amygdala. When your cat head bumps you, pressing its forehead or cheek against your skin, it's depositing its own scent while simultaneously reading yours. The exchange is mutual and chemical. Over days and weeks, a cat builds a chemical map of your emotional rhythms. Morning cortisol patterns, the scent signature of work stress versus social anxiety. Cats aren't reacting to emotions in the moment. They're tracking patterns across time. Olfactory memory in mammals is exceptionally durable. The hippocampus encodes scent-associated experiences with high fidelity, and cats retain individual scent profiles for years. Your emotional baseline isn't just detected, it's remembered and compared against. This is why a cat that's lived with you for years responds differently to your stress than one that's known you for weeks. The long-term resident has a reference library. The new arrival is still building one. The behavior looks similar. The depth isn't. The science here is still young. Most vomeronasal research has been conducted in large felids or rodents, and the precise compounds your cat detects in human sweat haven't been fully cataloged. The mechanism is confirmed. The full vocabulary isn't. What the research does confirm, calm is a detectable state. Lower cortisol, steadier breathing, reduced skin conductance, these produce a recognizable chemical signature your cat associates with safety. Your relaxed presence is information it actively uses. The practical implication is direct. If you want your cat to approach you, to settle near you, to behave with less wariness, the most effective signal you can send is biochemical. Slow your breathing, drop your shoulders. Your body will do the rest. Researchers studying canine and feline olfaction estimate that a cat can distinguish between your baseline scent and a stress-altered version within a single sniff, a discrimination that takes a trained human clinician, a blood draw, and a laboratory to confirm. Right now, in your home, your cat knows something about your emotional state that you haven't consciously registered yet. The question worth sitting with isn't whether it's reading you, it's how accurately and what it's already decided to do about it.